Electrical panel dividers serve a specific purpose, although they may not completely isolate high and low voltage sections. The primary function of these dividers is to provide a physical barrier, minimizing the risk of accidental contact with live conductors. Complete separation of the entire cavity is often unnecessary and impractical. Instead, the dividers strategically partition specific areas within the panel where high and low voltage components are in close proximity. This targeted separation enhances safety during maintenance and repair activities. For instance, when working on a low-voltage circuit, the divider prevents unintentional contact with adjacent high-voltage conductors. The physical barrier offered by the dividers significantly reduces the potential for electrical shock and other hazards. Consider a scenario where an electrician is troubleshooting a 120 volts lighting circuit within a panel. Without a divider, there's a higher chance of inadvertently touching a 277 volts or 480 volts conductor feeding a motor or other equipment. The divider acts as a safeguard, providing a clear visual and physical separation between these voltage levels. Furthermore, the dividers contribute to better organization and management of wiring within the panel. By creating distinct zones, the dividers make it easier to identify and trace specific circuits. This improves efficiency when adding new circuits or modifying existing ones. Proper wire management also reduces the likelihood of loose connections and overheating, enhancing the overall reliability of the electrical system. The dividers help to maintain required clearances between conductors. The National Electrical Code, or NEC, specifies minimum spacing requirements between conductors of different voltage levels. Dividers can assist in achieving these clearances, particularly in panels with limited space. This is important for preventing arcing and short circuits. In some cases, the dividers also provide structural support for the panel components. They can help to stabilize the mounting of circuit breakers, terminal blocks, and other devices. This ensures that the components remain securely in place, even under vibration or other mechanical stresses. The placement and configuration of dividers can vary depending on the panel's design and intended application. Some panels may have a single divider separating the main incoming conductors from the branch circuits, while others may have multiple dividers creating more granular separation. The specific arrangement is usually determined by the manufacturer to optimize safety, organization, and accessibility. The materials used for the dividers are typically non-conductive, such as plastic or fiberglass. This ensures that the dividers themselves do not pose an electrical hazard. The dividers are also designed to be durable and resistant to heat, moisture, and other environmental factors. To understand the importance of dividers, consider an example of a panel supplying power to a commercial building. The panel may contain a variety of circuits, including 480 volts for HVAC equipment, 208 volts for lighting, and 120 volts for receptacles. Without dividers, the close proximity of these different voltage levels would create a significant safety risk. The dividers help to isolate the high voltage circuits from the low voltage circuits, protecting personnel and preventing equipment damage. Another benefit of dividers is that they can help to reduce electromagnetic interference, or EMI. High-voltage circuits can generate EMI that can disrupt the operation of sensitive electronic equipment. Dividers can act as a shield, preventing EMI from propagating from one section of the panel to another. This is particularly important in environments where sensitive electronic equipment is used, such as hospitals, laboratories, and data centers. The installation and maintenance of dividers are important aspects of electrical safety. Dividers should be properly installed and secured to prevent them from coming loose or falling out. Damaged or missing dividers should be replaced promptly to maintain the intended level of protection. During maintenance activities, it is important to inspect the dividers for any signs of damage, such as cracks, breaks, or discoloration. Any damaged divider should be replaced before energizing the panel. In addition to physical dividers, some panels may also incorporate other safety features such as insulated bus bars and touch-safe terminals. These features provide additional protection against accidental contact with live conductors. Insulated bus bars are covered with a non-conductive material, preventing accidental contact. Touch-safe terminals are designed to prevent fingers or tools from touching the live parts of the terminal. The selection of an electrical panel with appropriate dividers and other safety features is a critical consideration for electrical system design. The panel should be chosen based on the specific voltage levels, current ratings, and environmental conditions of the application. The panel should also comply with all applicable codes and standards, such as the National Electrical Code, or NEC, and Underwriters Laboratories, or AL. When working on electrical panels, it is essential to follow safe work practices. Always de-energize the panel before performing any maintenance or repair activities. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. Never work alone, and always have a qualified electrician present. Before opening the panel, use a voltage tester to verify that the power is off. Visually inspect the panel for any signs of damage or hazards. Use caution when working near live conductors, even if they are insulated. Keep tools and other objects away from live parts. After completing the work, thoroughly inspect the panel to ensure that everything is properly installed and secured. Replace any covers or panels that were removed. Re-energize the panel and verify that it is operating correctly. Proper use and maintenance of electrical panel dividers are essential for ensuring electrical safety. Dividers provide a physical barrier that helps to prevent accidental contact with live conductors, organize wiring, and maintain required clearances. By understanding the purpose and function of dividers, electricians and other qualified personnel can work safely and efficiently on electrical panels. Let's consider a few more scenarios to illustrate the importance of electrical panel dividers. Imagine a large industrial facility with numerous electrical panels distributed throughout the plant. Each panel supplies power to various machines, lighting systems, and other equipment. The panels may contain a mix of high voltage and low voltage circuits, making it challenging to maintain a safe working environment. By installing panels with properly designed dividers, the facility can significantly reduce the risk of electrical accidents. The dividers provide a clear visual separation between different voltage levels, helping electricians to quickly identify and avoid potentially hazardous areas. In addition, the dividers help to prevent accidental contact with live conductors during routine maintenance tasks. For example, an electrician may need to replace a blown fuse in a 120 volts control circuit. Without a divider, there is a risk of accidentally touching a 480 volts conductor feeding a large motor. The divider acts as a barrier, preventing this type of accident. Another scenario involves a data center with sensitive electronic equipment. Data centers rely on a constant and reliable supply of power to keep their servers and other equipment running. Any interruption in power can lead to data loss and significant financial losses. Electrical panels in data centers often contain a mix of high voltage and low voltage circuits, as well as sensitive electronic components. Dividers can help to reduce electromagnetic interference, or EMI, which can disrupt the operation of the electronic equipment. The dividers act as a shield, preventing EMI from propagating from one section of the panel to another. In addition, the dividers help to organize the wiring and maintain proper clearances, reducing the risk of short circuits and other electrical problems. A further example is a hospital where the safety of patients and staff is paramount. Hospitals rely on a complex network of electrical systems to power medical equipment, lighting, and other critical services. The electrical panels in hospitals must be designed to meet strict safety standards, including the use of dividers. Dividers help to prevent accidental contact with live conductors, reducing the risk of electrical shock to patients and staff. In addition, the dividers help to organize the wiring and maintain proper clearances, ensuring that the electrical systems operate safely and reliably. The National Electrical Code, or NEC, provides specific requirements for the installation and maintenance of electrical panels. Article 408 of the NEC covers switchboards, switchgear, and panel boards. This article includes requirements for the construction, installation, and wiring of these types of equipment. Section 408.3 ATWO addresses the separation of voltage levels within a panel board. It states that barriers shall be placed in panel boards to separate wiring and terminals of different voltage levels. This requirement helps to prevent accidental contact with live conductors and reduce the risk of electrical shock. The NEC also includes requirements for working clearances around electrical equipment. Section 110.26 specifies the minimum working space required in front of electrical equipment. These clearances are intended to provide sufficient space for electricians to safely work on the equipment. In addition to the NEC, other standards may also apply to electrical panels. Underwriters Laboratories, or UL, is a testing and certification organization that develops standards for electrical equipment. UL Standard 67 covers panel boards. This standard includes requirements for the construction, performance, and safety of panel boards. Compliance with UL Standard 67 ensures that the panel board has been tested and certified to meet safety standards. It's also worth noting that while divisors are essential for safety, they are just one component of a comprehensive electrical safety program. A complete program should include regular inspections, maintenance, and training to ensure that electrical systems are operating safely and reliably. Electrical safety training should cover topics such as lockout-tagout procedures, personal protective equipment, and safe work practices. Employees should be trained to recognize electrical hazards and take appropriate precautions to prevent accidents. In summary, electrical panel dividers are an important safety feature that helps to prevent accidental contact with live conductors, organize wiring, and maintain required clearances. While they may not completely separate the entire cavity into high and low voltage sections, they provide a targeted separation that enhances safety during maintenance and repair activities. By understanding the purpose and function of dividers, electricians and other qualified personnel can work safely and efficiently on electrical panels. Always consult the National Electrical Code, or NEC, and other applicable standards for specific requirements related to electrical panel installation and maintenance. Remember to prioritize safety in all electrical work and seek guidance from qualified professionals when needed.